Good morning. Today we're covering section 3.4. We're solving systems or linear equations, but now it's going to be in three variables. We're going to be working with a system, and I know it looks a little bit overwhelming when you first see it, but it's actually not too difficult to work out. It's just a little more work than the ones we have covered before. So let's go over example number 1. We're going to be doing it by combination. So remember, when we're working with combination, we want to be able to cancel the x's, the y's, or in this case, the z's. So as I look through this, I know I need to decide which ones am I going to cancel. And the x's look much easier to cancel because this one's will automatically cancel. I can just multiply the middle one by 3 to cancel it with this one. But we're going to do it in 3 different steps. Step number 1, we want to be able to grab 2 of the equations so we can cancel the x. So we're going to grab 2 equations and we're going to cancel the x. In this case, we're going to take the first and the second equation. We have x minus 6y minus 2z is equal to negative 8. The second one is negative x plus 5y plus 3z is equal to 2. I want to be able to cancel the x's, so if you notice, automatically the x's cancel. I'm going to combine both equations. That gives me negative 1y, or just negative y, plus z is equal to negative 6. Now, I want to do it once again, and I want to cancel the z's once again. The x's once again. So I'm going to cancel the x's once again, and I'm going to grab 2 other equations. So let's see, I can grab the second one and the third one, or if you want to grab the first one and the third one, that will work as well. Now, in order to cancel the x's, I'm going to multiply the top one by positive 3. So that way, the x's, this becomes a negative 3, and a positive 3 will cancel out. I'm going to multiply it out. That gives me negative 3x. Just be very careful when you multiply, because if you mess up on one item, the whole process will be wrong. That gives me 9 z is equal to 6. Now, very important that write down the number they're going to multiply right here, so you can go back and double check, and also do your arrows. So I can go back and check, which ones do you combine, and you can go back and check and see if you catch any mistakes, if you do make any. The third one will stay the same. 3x minus 2y minus 4z is equal to 18. I'm going to combine it. The x's cancel, just like we wanted to. This will give me 13y plus 5z is equal to 24. And I usually double check my work. This is a long process, so if you make one small mistake, then you're going to have to repeat or go back and check your work, and it makes it a little challenging. Now that we finished with canceling the x's twice, on step number 2, let's go and write down both equations that we ended up with. Negative y plus z is equal to negative 6, and then we have 13y plus 5z is equal to 24. And now we're going to combine it once again. Now if you notice, now that we have step number 2, it's just like the problems that we used to have on the previous section, when we have 2 equations with 2 variables. So I'm going to cover this up, and it's nice to be able to cover up so that way you're not getting overwhelmed on what will be the next step. So now I want to be able to cancel the y's or the z's. If I look at this carefully, probably the z's, just because that will give me a smaller number. So I'm going to multiply the top. I want to make this a negative 5z, so it cancels. So I'm going to multiply the top by negative 5. I'm going to rewrite it on the right hand side. That gives me positive 5y minus 5z, and negative 5 times negative 6 will give me equal to positive 30. Double check that I multiply correctly. That's fine. I'm going to rewrite the bottom. 13y plus 5z is equal to 24. Just like I wanted, I cancel the z's. I'm going to combine it. So it gives me 18y is equal to 54. I'm going to divide by 18. And 54 divided by 18 will be just 3. Now, on all of the problems I'm giving you guys, I'm giving you guys whole numbers. So that way, if you get a fraction anywhere as an answer, you can go back and double check. So now that we solve for y, we can solve for x, in this case actually, for z, just like we've done before. So we're going to substitute. And I want to substitute into either one of those two equations. So I usually substitute into the one that has smaller numbers. So the first one, so be negative y plus z is equal to negative 6. But instead of the y will be a 3. So be negative 3 plus z is equal to negative 6. I'm going to solve for z. So I'm just going to move the 3 to the right. It becomes a positive 3. So that gives me z is equal to negative 3. And now that I found two variables, I can plug it in into any of those three equations. Because now that I have the value of two variables, if I plug them in, I can solve for the one that's remaining. And that'll be, we'll call that step 3. So let me box in my steps. So step 1, step 2, and step 3. Kind of makes it a little more organized. Instead of the, I'm going to use the one that has smaller numbers, so I'm going to use the second one. It really doesn't matter, you can choose whichever. You can plug into the first one, the second one, or the third one, you still get the same result. So negative x plus 5, instead of the y will be a 3, plus 3, instead of the z will be negative 3, and it's equal to 2. So negative x plus 15 minus 9 is equal to 2. So negative x, combine those two, gives me positive 6 is equal to 2. Negative x is equal to, move this to the right, that becomes a negative 4, or negative 6. So this is a negative 4. So if negative x is equal to negative 4, divide by negative 4, x is equal to positive 4. So my solution, where all three planes, in this case, intersects, will be 4, 3, and negative 3.